So 17A is distributive property. Am I up there? Yeah, okay. Whew, this is going to be a long day in this heat, huh? Okay, no, we're not doing basketball right now. We're doing distributive property. Okay, here's how the distributive property works. If I gave you this and this, could you tell me how you would find the area of this rectangle? Do you remember the area formula? What is it? What? What? You multiply, right? It's base times height, okay? So that's kind of how we're going to think about this. But 8 times x plus 5, we don't necessarily know how to do. The distributive property will tell us how to do 8 times x plus 5. So the way that you can kind of think of it as a picture problem is you can break it up so that you have 8 here, but now let's make it 2 rectangles. We'll put the x portion here and the 5 portion there, okay? Now ignore this for now. What is the area of this box? 8 times x, right? That's 8x. Okay? All right, now, oh, you know what? I got to back up because I want that x to go away. Sorry. You can leave it. You can leave it. So we just said this is 8x, right? Now we're going to ignore the second box, and we're going to look at this box. What's the area of that box? It's not 5. 8 times 5, right? This side dimension is 8. The bottom is 5. 8 times 5 is 40. Okay? So if I wanted to know the area of the whole thing, what would I do with the 8x and the 40? Add them together, okay? Now you can't add those, so it just becomes 8x plus 40 because they're not like terms, okay? We just did the distributive property without realizing you did the distributive property. Here's what the distributive property does. We want 8 times x plus 5. What you do is you distribute the 8 to everything else in the parentheses, okay? You guys with me back there? You with me? I don't know what she's doing, but you're watching what she's doing instead of what I'm doing. I'm talking to you, Noah. Are you with me? Yeah? Okay. So let's distribute. We're going to go 8 times x, which is 8x, and we're going to go 8 times 5, which is 40, and we were adding, so we're going to keep adding. Okay? So what we did here and what we did here are exactly the same thing. 8x plus 40 versus 8x plus 40. If pictures make more sense to you, draw a picture every time. It's going to take you a lot longer, but you are welcome to do it, okay? Let me give you a couple more of just a basic setup of this. If I tell you 2 times x plus 3, okay? Distributive property would make that what? 2x, right? 2 times x plus, because we're adding, 2 times 3 is 6. So that's what it would simplify to, okay? That's the distributive property. What if it looks like this instead? What are you distributing? The 6, okay? The 6 is it's whatever is outside of the parentheses by itself has to get multiplied by everything inside the parentheses. So if we distribute this, what do you get here? 6x. What do you get here? Minus 24, right? We're subtracting, so keep subtracting. So 6x minus 24 would be your distributive property. Have you done distributive property before? Does this look familiar? Okay. I feel like every year people are like, yeah, this is so easy. Why are we like spending so much time on it? And every year I have a handful out of a class of 15, I have 5 of them that just don't remember to distribute. So this is me begging you right now to remember to distribute, okay? Take that number and multiply it by everything that's inside of the parentheses. Can we do that? You guys are great, so you're totally going to do it, right? Totally going to do it. Okay, here it is. We're just going to do a few of those together. So here's your first one. I'm going to give you 2 for you to work out. And then we'll go through them together. So do that one and do this one. This one looks a little different, but it's the same idea. Okay? Try those 2 right now. All right, what'd you get on the first one? 3x plus 24. So it's the 3 times x is 3x plus 3 times 8, which is 24. Okay? What'd you get on the second one? It's not negative 2y. What's y times y? It doesn't cancel. So, okay, think of it this way. What if I said a times a? What's an easier way to write a times a? Not 2a, a squared, right? So if I'm doing y times y, there's got to be a y squared there. Does that make sense? So this is like a -1 out in front, if you want to think of it that way. So you're doing -1 times 2 is a -2, and then y times y is y squared. Okay, that one's a little tricky, right? Take your time on those. So that's a -2y squared. What is this, the second part of it? It's a -1 times a -1 times y. What's -1 times -1? +1. And then you have y. So we're adding here because essentially we were subtracting a negative, right? Minus a negative is plus a positive. So all you have left from that is a y. So it would be -2y squared plus y. Does that make sense? Okay, if you multiply a variable times itself, it squares, right? X times x is x squared. Y times y is y squared. Keep that in mind if you're multiplying 2 variables. Okay, what about this one? 4 minus x times, actually we won't put parentheses. So 4 minus x and then times 11. What do you get from that? Okay, so that's interesting. Right, you have to go in the order they're in because it's 4 minus x, not x minus 4, right? So you have to start with the one on the left. So 11 times 4 is 44. And then you have your sign, so minus, and then 11 times x is 11x. Is that the same as 11x minus 44? No. Okay. What, Olivia? Are you sure? Yeah. So you just have to make sure you go in the order it's given. This one first, this one second. Okay? Okay, this one's a little tougher too. You have 3 times 1/6x plus 2. So you have a fraction now. But you guys know how to multiply fractions. What do you do first? 3 times 1/6 x, right? So if you want to rewrite it, this is like 3 over 1 times 1 over 6 times x. So if you just multiply across there, you get what? 3 over 6. So it's 3 over 6x, but what is 3 over 6? 1 over 2, right? Divide both by 3, so you get 1 over 2 x. So every one of these is equal, right? This equals this, which equals this, which equals this. So we're just simplifying 3 times 1/6, okay? So 3 times 1/6 x is actually 1/2 x. So we just did this step. Now you got to do the next step. What is the next step? 3 times 2, which is 6. Are we adding or subtracting? We're adding because the problem is adding. Okay, so your answer is 1/2 x plus 6. Okay? Are you good on that? Okay. What about this one? 5 times x minus 7. What is that going to become? There you go. So 5 times x is 5x. 5 times 7 is 35, and we were subtracting, so keep subtracting. So this is your simplified. Okay? Okay. Now we're going to do it in reverse. We're going to take the distribution out. Okay? So here's what you need to remember. Remember that a over b, or a divided by b, is the same as saying a times 1 over b, right? Those are the same thing. A divided by b is the same as saying a times 1 over b, okay? Because if I were to multiply across right here, 1 times a is a over b, okay? So keep that in mind when you do a problem that looks like this. They're going to ask you on these ones to write the sum or difference. Okay, so this is going to start out looking like a division problem. They want it to be an addition or a subtraction problem. Okay, so you have to write it as a sum or difference instead. So here's your first example. You have 7x plus 2 over 5. Okay, now keep in mind what we said over here. Right now, it's set up like this, something over something. Well, that top something can go by itself, and then the bottom something can become a fraction that we're multiplying by that other something, okay? So the way you think of it is this becomes the thing in your parentheses, okay, 7x plus 2. And what fraction would we multiply it by? What is this 5 going to do to make it a fraction? 1 over 5, right? There's essentially this 1 out in front. 1 over 5 would be the same thing. So this right here is the same as this. It just looks different, okay? But then that helps you so that you can distribute and solve, okay? Which we're not even going to distribute right now. Actually, we'll distribute. Let's distribute. So if I distribute this, what's 1/5 times 7? 7/5, right? You just multiply the 1 times the 7 is 7/5, and we still have our x there. Plus, what's 1/5 times 2? 2/5. Okay, so this is the same as that. Does that make sense? Do you see what's happening here? Because this is kind of a shortcut, and I'll tell you the shortcut. You don't have to use the shortcut. But when you do this, this becomes a fraction. See that? 7x over 5. And this becomes a fraction, 2 over 5. Okay? So it's kind of a shortcut for you if you want shortcuts. Okay, so let's look at this one. You have 4x minus 16 over 3. And I want to turn that into a sum or difference. So right now it's a division problem. I want to do an addition problem or a subtraction problem. Is this going to be addition or subtraction? subtraction, okay? The non-shortcut would say what fraction is getting multiplied by the 4x minus 16? 1/3, right? 4x minus 16 would be getting multiplied by 1/3. So you either distribute that, or the shortcut says make this a fraction. So 4/3 times x minus, and make this a fraction, 16/3. And that will be your distributed answer. Questions on that? Okay, last one. And I'm going to have you try this one on your own, and then we'll do it together. So 4 minus 2x over 8. That's your problem. So you have what fraction out in front? 1/8. Okay, so you're doing 1/8 times 4 minus 2x and distributing that. Or if you like the shortcut way better, you're doing this and this with subtraction in between, right? So it's 1/8 times 4, which is 4/8, minus 1/8 times 2x, which is 2/8 times x. What do those reduce to? What are 4 and 8 both divisible by? By 4, right? So divide both by 4, you get 1/2. Okay? 2 and 8, what are those both divisible by? By 2, okay? So divide by 2, you get what? 1/4 x. So this is your most simplified answer, okay? And then you'll just leave it like that. Any questions on that? Okay, so we're all going to do the distributive property every time. Because I'll tell you right now where people make mistakes with distributive property is this. If I give you 3 times x minus 7, for instance, if that's like inside of a problem where there's all kinds of other stuff going on too, people see this and they go, oh, it's 3x minus 7. They forget to do the second part of it. Make sure that you're getting 3x minus 21, okay? Make sure you're distributing to both things. People always do the first one, and then they always forget the second one, okay?
We don't have to switch it.
Okay, so Zion's asking this. Do you switch these, right? Because usually it's the x comes first and then the non-x. If you switch them, this minus stays with it. So you would have to call it negative 1/4 x, and then it's a positive 1/2. So this is the same thing, that's fine, but you cannot say 1/4 x minus 1/2. That's different, okay? It's a good question, though.